we're ready to look at section 4.3 here, and that section, we're just going to review quickly here how to solve right triangles and do some applications with them. You can remember SOHCAHTOA, and the SO part of it is the sine ratio of opposite to hypotenuse. The CA is the cosine ratio adjacent hypotenuse, and tan is the TOA, opposite to adjacent. The other three ratios are their reciprocals, and you want to make sure that you correct this last one with this little bit of a typo. It's adjacent over opposite. All right, we are going to look at how to solve the right triangle here. You might want to label some of these sides. Let's call this angle A here. We're going to assume that angle C is a right angle. And in order for us to start solving the right triangle, we can find the missing angle. Let's find angle A. The side opposite is 15, hypotenuse is 28, so that is the sine of angle A is equal to 15/28. In order for us to find that, we do inverse sine of 15/28. And we're able to use your calculator, making sure that you're in degree mode. And when you calculate that, you'll get the angle to be 32.4 degrees. 32.4. All right, so there's your first measure. That's angle A. Right here. All right, your next angle, we can subtract the two acute angles here from 180 along with the right angle from 180 and the acute angle, or you can just do 90 minus the 32.4. And when you get that result, we would get 57.6. So angle B is the 57.6 degrees right here. And the last thing that we want to do is find side little b, which is here on the bottom, the base. You could use the Pythagorean theorem to get it, or what you can do is you can set up one of your ratios. We could do cosine of angle A, where A is 32.4. That would equal side B over 28. To find that measure here, we would find the cosine of 32.4, multiply by the 28, and we get a B value of 23.64. So there's the third measure. That's how you solve a triangle. You find all the missing parts. All right, example 2. Application problem. It says a 30-meter line is used to tether a helium-filled balloon. Because of a breeze, the line makes an angle of approximately 75 degrees with the ground. Draw and write a triangle that gives a visual of the representation, and then what is the height of the balloon. So we've got the balloon 30 meters on a line, and then angle is 75 degrees. This is what I've visualized. Here you have this balloon, and it's tied to a 30-meter string, and since the wind is blowing in a certain direction, now the balloon is over here. So the balloon is traveling this direction with the wind, and we want to know how high the balloon is off the ground. All right, your angle of elevation, or the angle with the ground, is 75 degrees. We know that this measurement right here, this 30, the wind is blowing it this way, so the 30 is my hypotenuse, 30 meters. And what they're asking us to find is the height, h. Well, what I know is that the height is the opposite side. 30 is the hypotenuse, so we can go sine of 75 degrees equals h over 30 meters. And you would cross multiply the sine 75 times 30, so height would equal, and you can go ahead and round maybe to the nearest hundredth, 28.98 meters. The key to doing your application problems is getting your drawing so that it is accurate and you have your angles and sides measured and labeled in the right position. All right, last problem. In traveling across flat land, you noticed a mountain directly in front of you. Its angle of elevation to the peak is 3.5 degrees. After you drive 13 miles closer to the mountain, the angle of elevation is 9 degrees. Approximate the height of the mountain. So you're traveling along flat ground. We've got a mountain. I guess what we assume is that the mountain is being measured like as an altitude, so there's the height. At first, you measure the angle of elevation to the top of the mountain to be 3.5 degrees. And then later on, you measure it to be, this is not drawn to scale, to be 9 degrees. And you'd walked 13 or had traveled, it says 13 miles closer to the mountain. All right, we are supposed, those are the only two measures that we know. These are the angle measures, 9 and 3.5, and we're supposed to find the height. Well, the only way for us to figure out height is if we include this being a right triangle. You've got the inside right triangle right here, and then you got the large right triangle. And for both of those triangles, we can set up a tangent expression. So let's do tangent of the small triangle. So we have tangent of 9 degrees equals h over, and what we have to do is we have to insert a variable, let's call it x, because we don't know what it is. And now what we're going to do is we're going to go the big triangle. We'd have tangent of 3.5 equals h over, and then it's 13 plus x. That's just the segment addition postulate. If we can go through this process here and find what our h is equal to, or even what x is equal to, then we would be able to solve for the height. All right, we got a system of equations. I'm going to take my system of equations and I'm going to isolate for h. So tangent 9 times x is equal to h. And I'm going to isolate for h on the second equation. That is tangent of 3.5 times 13 plus x is equal to h. Well, here's what we know, that if both of those expressions are equal to h, then they're equal to each other. So we've got tangent of 9 times x equals tangent of 3.5 times 13 plus x. We just have to solve for x here. So tangent of 9 is 0.1584. And you can use your calculator for that. And tangent of 3.5 is 0.0612. I went ahead and rounded to 4 decimal places. We're going to go ahead and distribute. So we've got, on the left side, we still have 0.1584x. On the right side, if you take 0.0612 and multiply it by the 13, you get 0.7956. Plus 0.0612x. Combine our like terms, move our x's to the same side, and we would get 0.0972 x equals 0.7956. Divide, so x would equal 8.19. Now what we're going to do is we're going to take that 8.19 and we're going to go up and try to solve for one of my equations. So if I put 8.19 right in here, 8.19, then I can do tangent 9 multiplied by 8.19. So you got tangent of 9 times 8.19 equals h. And so the height is, final answer, Our height is 1.297 miles. All right, that is it for this section. Section 4.3, which is reviewing how to solve right triangles and use application problems with right triangles.